this simple problem. This is a simple problem. People, you know how to represent circles. This circle has a center AB. So let's find this AB. It has a center which is not at the origin. So it's not for that first situation, it's for the second situation, a circle with center AB. So what are the coordinates of the center? Easy, right? You start with the x, it is -2 on the real. So it is -2, comma, what? Here, 1. So we can say it is -2, 1. That is if we were using the Cartesian plane, right? If I now want to represent it as a complex number, I know that this is a 1 on the I, on the imaginary plane. So I can say, this is my Z1. Remember, I told you that Z1 is going to be for the new center. Z is going to be for any point on the circumference, measuring it from the origin. Okay? So this is my Z1. Z1 is going to be what? -2 plus 1i. Okay, so it's plus 1i. So it's plus 1i. If you want, you can just say -2 plus I. Can you see that? This is my Z1. Now, they said find two inequalities that, in terms of Z, that define the shaded region. Now, remember, what is the first thing we need? We want to have Z. We want to find the shaded region. How we define the shaded region. The shaded region, you can see it is inside the circle. Remember, we say that when I say modulus of Z minus Z1 is equal to R, I'm getting points that are on the circumference. If I want points inside, I use inequalities. Z minus Z1 is less than R. I get strictly inside without including the boundaries. And for that, the circle would have been dashed. Okay? But now, because the circle is solid, that means I can also take the boundary. I'm shading the inside, but I can see that the circle is also dashed. So that means I'm including it. So it's kind of say Z minus Z1 is less than or equal to R. We want points inside here and including this boundary here. Okay? So first we want points that are inside the circle, but then we want only points that are inside the circle and lower than this line here. So they should be inside the circle and they should be lower than this line. So points that are lower than this line. What is this line? We can see that this line is not changing a value. It's changing on the real. On the real, it's representing many things. But since it's horizontal, it is not changing a value on the imaginary thing. And that value is minus I. So we can see that the imaginary is actually never ever going above minus I. So it should be less than or equal to negative I for the imaginary. Can you see that? Right? The imaginary of Z. So if we were to put it, we would say. So now when we put it as an equation, we don't have to put the I now. When we put it as an inequality. So what we would say, because we already know that we are on the imaginary axis, we would write and say imaginary of my Z should be less than or equal to minus 1. Okay? The imaginary. Because I want it to be below this minus 1 on the imaginary. It's minus 1i. So find the two inequalities. First of all, I can already see that the imaginary should be less than or equal to minus 1. Now let's do for the second one, right? Let's do for the second one. What should we have? We know that the modulus, we are going to write for the second one, we have modulus of Z minus Z1 should be what? Less than or equal to R. Now, what is my R? Let's find it. That's the one we are using. We are using this one. We want them to be inside the circle. So let's find our R. Our R is from here to here, which is going to be 1, 2, 3. Our R is 3. So we are saying we are now going to say here, okay? So let's say the other one was the modulus of Z minus Z1 is less than or equal to R, which is the modulus of, should be less than or equal to 3. My R is 3. So what is the modulus of Z minus Z1? Z will not go anywhere. We have found my Z1. We found Z1. So we said, Z1 is equal to what? We found its coordinates. It's just from the coordinates of the new center. It's -2 plus 1i, right? That is my Z1. So it is -2 plus I. This is my Z1, okay? So now I'm going to say the modulus of Z minus Z1. I open brackets, minus, what is my Z1? -2 plus I. This should be, modulus of this is less than or equal to R, which is 3. This is the other inequality, right? Now you can distribute the negative. So you'd say the modulus of Z minus becomes plus 2. Then minus of I becomes minus I. This modulus is less than or equal to 3. And I would be done. I would be done. So imaginary Z is less than or equal to 2. Then the other one, the modulus of Z plus 2 minus 1i is less than or equal to 3. We just wanted points inside the circle, which we learned that inside is for this. For any circle that has a center AB, a center which is not at the origin. And we said Z1 is from the coordinates of this thing. You just change them to be complex number form. You understand? Exactly. And you should make it equal to r. And we found the r because it's just the distance. We saw it to be 3. We don't care about the whatever distance in what, because r can be in this way, it can be in this way, it can be in that way. It's still just going to be 3. So you don't say 3i or 3z, whatever. It's just 3. This is going to be it, and we are done. Here are the two inequalities, and we are done with this question. I hope you have seen it. It is not hard. No, it is not. Now let's go and do the second one. Goodbye for now.